In this video, let's go through a chi-square test of independence from start to finish using survival among the Titanic crew as our example. Specifically, let's look at whether the probability of a crew member surviving the sinking of the Titanic, whether that was independent of the type of position they had on board. Did they work for the White Star Company, the company that owned the ship, as sailing crew? Did they work for White Star as non-sailing crew, presumably other support staff around the ship? Or did they work for some other company, maybe the musicians or others like that? For the example, we'll set our alpha at 0.05, all right? And let's get started. Now, notice we have two categorical predictors, right? One is employment, which consists of three groups: White Star sailing crew, the White Star non-sailing crew, and non-White Star employees. We have a second categorical variable, whether or not someone survived, which consists of two groups: those who survived and those who didn't. Now, our hypotheses are easy with a chi-square test of independence. The null hypothesis is just that the probability of being in any group for one categorical variable is independent of which group someone is in for the other categorical variable. And the alternative hypothesis is that the probability of someone being in any group for one categorical variable is not independent of which group they're in for the other categorical variable. All right? Now, applying this to our specific problem here, we could say that the null hypothesis is the probability of survival being independent of employment group. In other words, the probability of surviving is the same for all three groups of employees. And the alternative hypothesis could be stated as the probability of survival not being independent of employment group. In other words, the probability of surviving is different across the three groups of employees. Now, you could state your hypotheses in terms of whether the probability of being in a different employment group was independent of whether someone survived or not. But it's actually exactly the same thing, just framing the relationship from the other direction. So the test and the results would be exactly the same, regardless of which way you frame it. But in this case, talking about the probability of surviving based on one's work group is more clear, at least to me, and certainly more interesting. All right, so we're going to go with this way of framing it. All right. Now, let's take a look at the breakdown of the crew. Here we've summarized how all of the crew fell into these two categorical variables. There are 6 boxes or cells, right, reflecting the combination of 2 survival groups and 3 work groups. Notice we have a total of 918 crew members, and each person fits into one and only one of these 6 different cells. Right? Now, we could begin by just eyeballing this a little bit. Right? Notice that 215 crew members survived, which is about 23% overall. But notice that among the 61 sailing crew, 42 of them survived. That's about 69% survival for that group. On the other hand, among the 91 non-White Star crew, only 4 survived, which is less than 4%. Ouch! So it does look like survival may not be independent of employee type. But is this statistically significant? Is this difference that we're seeing significant? Or is it just random chance? Right? Well, let's calculate our chi-square and find out. To start, we need to estimate the expected number that we would see in each cell, that number that we would expect for each combination of survival status and crew type, if survival status and crew type were independent. We do that by using the formula that the expected number for a given cell equals the number in the corresponding column times the number in the corresponding row divided by the total number in the sample. We just plug those numbers into this equation, and let's enter that equation then into each of the corresponding boxes. All right? So first, let's do the expected number of survivors in the sailing crew. That would be 61 times 215 divided by 918. So let's enter that equation up here, right? Next, let's do the number of survivors among the other White Star employees. That would be 766 times 215 divided by 918. So we'll take those numbers and put it into the equation for this box, right? And finally, let's do the expected number of survivors in the non-White Star crew. That would be 91 times 215 divided by 918. We'll take those numbers and put that equation up here. All right? Now, let's pause the video, and why don't you write the formulas for the expected number of crew who did not survive and enter those in the 3 cells for that row. All right? Start the video up again when you're ready. Did you get these equations? The expected number of sailing crew who would not survive would just be 61 times 703 divided by 918, while the expected number of other White Star crew who would not survive would be 766 times 703 divided by 918. And the expected number of non-White Star crew who would not survive would be 91 times 703 divided by 918. All right? Great. Now, if we solve each of these equations, we get these values, right? For example, we see 14.286 sailing crew members would be expected to survive. Now, notice that the expected numbers can be fractions. It's not that we literally expect 2.286 of a person to appear in a lifeboat. That would be disgusting. It's that these are theoretical mathematical values that you would get given the number of survivors and type of employees if survival status and employee type were completely independent. So fractional values are okay. Don't round them to whole people, right? Now, let's use these values to calculate our chi-square. The formula for the chi-square, again, is the frequency for a cell, the observed frequency for a cell, minus the expected frequency for that cell, that difference squared, and divided by the expected frequency for that specific cell. Then we repeat it for each of the combinations, each of our 6 cells, and add them all up. Right? That gives us our chi-square value. So to do that, we need to use both the observed and the expected values for each combination of survivor status and crew type. Now, that's going to get a little crowded, so let's clean things up a bit and try to squeeze everything in. Let's first put the chi-square formula up at the top to remind us what we're doing. Then let's add the observed values here and the expected values here. I've shrunk them a bit to give us a little more room to work with, right? And then to organize the calculations that we're going to be doing for each of the 6 cells, let's add an empty table based on survivor status and crew type, where we'll enter the calculations for each of the cells. All right? So with that, now we're ready to do some work. All right? Let's do a few so that you see what I mean, right? Now, using our chi-square formula, what's the equation for the value that we're going to enter for the sailing crew who survived? Well, that's the frequency of observed sailing crew survivors, or that's the 42. Notice that we get that from the observed frequency table, minus the number of sailing crew that we would expect to survive if survival and crew type are independent. That's 14.286. We get that from the expected frequency table. We take that difference, we square it, and then we divide by the expected frequency of 14.286 again. Right? So if we write that out in our equation, this is what we get. 42 minus 14.286, that difference squared divided by 14.286. Great. Now, remember, that's not the chi-square value, it's just part of it. We need to do this for all 6 combinations of survival and type of crew, and then add all of those up. So let's keep going, right? Next, we'll do the formula for survivors among the other White Star crew. Now, that would be 169 from the observed frequency table, minus the expected number of survivors, again assuming it's independent. That's 179.401. We take that difference, square it, and then divide by 179.401, the expected frequency again. If we write that down, we get 169 minus 179.401 squared divided by 179.401. All right? Now, let's keep going with the formula for survivors among the non-White Star crew. That would be 4 from the observed frequency table minus the expected number of survivors, 21.313. We take that difference, square it, and divide by the expected frequency of 21.313. We write it down here, and again we get 4 minus 21.313, that difference squared, divided by 21.313. All right. Now, why don't you pause the video and write down the formulas for the non-survivors and each of the 3 crew types, 3 crew groups, say that 10 times fast, the crew groups, okay, write those down there, and then start the video up again when you've written down the equations. All right? Is that what you got? The formula for the sailing crew who did not survive would just be 19 minus 46.714, that difference squared, then divided by 46.714. Now, students will sometimes make the mistake here and divide by the observed frequency for the cell, divide by the 19 instead of the expected frequency of 46.714. Don't make that mistake. It's dividing by the expected frequency, okay? Now, continuing on, the formula for the other White Star crew who did not survive would just be 597 minus 586.599, that difference squared, and then divided by 586.599. And the formula for the non-White Star crew who did not survive would be 87 minus 69.687, that difference squared, and divided by 69.687. Great. Now, let's solve each of these 6 equations, and that gives us these values. We simply now add up all 6 of those to get our chi-square value. But before we do that, let's take a quick look at a couple of things here. Notice that the values for the other White Star crew are pretty small. They're all less than, well, they're both less than 1. That tells us that their actual observed numbers of survivors and non-survivors is pretty close to the numbers we would expect to see if surviving was independent of crew type. On the other hand, let's take a look at the sailing crew. Their values are very large. That tells us that their actual observed numbers of survivors and non-survivors is relatively very different from the numbers we would expect to see if surviving was independent of crew type. And if we look, they really are different, aren't they? There's way more survivors and far fewer non-survivors among the sailing crew than we would have expected, right? Now, let's get back to work and add these all up to get our chi-square value, right? First, let's clear some space again, okay? And now let's do the math. The chi-square is just the sum of 53.764 plus 0.603, right? Plus 14.064 plus 16.442 plus 0.184 plus 4.301. I think I got them all. We sum up all of those and we get a chi-square value of 89.358. Great. Now remember, we need to also calculate our degrees of freedom, which for the chi-square test of independence is just the number of rows minus 1 times the number of columns minus 1. Or for this example, it's 2 minus 1 times 3 minus 1, or 2 degrees of freedom. We can then write out our chi-square results using proper notation as the chi-square, and then in parentheses, the degrees of freedom 2, comma, the sample size of 918 as n equals 918, and our parentheses equals 89.358. Don't forget the degrees of freedom, and remember to include the sample size as well. All right? Finally, let's get our p-value. Now, of course, you can use any statistical calculator or Excel or something, but let's use the chi-square magic Google sheet. Now, if we open chi-square magic, this is what we see. We know our chi-square value, and we need the area or probability associated with that. So be certain to pick the chi-square score to area tab, right? And once you've done that, then enter the chi-square value of 89.358 and the 2 degrees of freedom into the corresponding yellow cells, right? Asking for that information. Once you've entered those, the blue cells show us the area above and below our chi-square value. Now, we want the area that's more extreme than our chi-square value, right? That's the probability of getting a chi-square value of 89.358 or more, right? With 2 degrees of freedom, if the null is true and survivor and employment group are independent, right? That's our p-value. Great. Now, in this case, what do we see? We see our p is less than 0.001. So we know that we're going to reject the null hypothesis, right? But what does this look like visually? Let's take a look. Here's a chi-square distribution with 2 degrees of freedom. Now, this is the frequency distribution for chi-square values that we would expect to obtain just randomly if the null is true. In this case, our chi-square value is 89.358, and it's way out there. It's off our scale here. So let's rescale the axis a little bit so that we can show chi-square values all the way up to 120. Okay, now we can see our chi-square of 89.358. It really is way out there. And you can see that the area under the curve is so small, we can't even see it anymore. But we do know that the area beyond 89.358 is less than 0.01, right? That's our p-value. That's what the p-value tells us. Now, what would be our critical chi-square? That chi-square value beyond which the area is equal to our alpha level of 0.05, right? The critical chi-square value is that line in the sand, that chi-square value we need to cross or exceed in order to reject the null hypothesis. Now, to determine that, let's go back to chi-square magic. Okay? Let's open chi-square magic. In this case, we know the area that we want, and instead we need to find the chi-square value associated with that area. So be certain to pick the area to chi-square score tab, and then enter the area for our critical score that we want in the yellow area cell, right? That's our alpha level at 0.05, right? We want to know the chi-square score that has 5% of the distribution more extreme than it. Now, remember, you also need to enter the degrees of freedom, so make sure you put in the correct degrees of freedom, 2 in this case, into the yellow degrees of freedom cell. Once those are entered, the blue cells give us 2 chi-square values. The first is the chi-square value below which, in this case, only 5% of the distribution lies. That's not the one we want, right? The second is the chi-square score beyond which 5% of the distribution lies. That's the one we want. That's our critical chi-square value, right? That's our chi-square value beyond which 5% of the distribution lies, with 2 degrees of freedom. And here we see that that's equal to 5.991. That our critical chi-square is 5.991. Great. All right, let's add this information back to our chi-square distribution. All right. So here in red is our critical chi-square value of 5.991 with 2 degrees of freedom, right? And the area above that is equal to our alpha level, is equal to 0.05, right? Or 5% of the distribution is more extreme than a chi-square value of 5.991. Great. If we get a score that's beyond that, we're going to reject the null hypothesis, right? So this is our region of rejection. And again, our obtained chi-square value of 89.358 is way into the region of rejection. So we know we'll reject the null hypothesis. All right. Now, with that, I think we're ready to summarize our results. So here's where we left off at the start of the problem. We have our research question regarding whether survival among crew members of the Titanic was independent of their employment group. We also set our alpha level at 0.05. We only wanted to make a type 1 error and reject the null when it's true 5% of the time, right? We had 2 categorical variables. Employment status, reflecting whether someone was a White Star sailing crew, White Star non-sailing crew, or non-White Star employee. And we had survival status, reflecting whether or not they survived. Right? Our hypotheses were very straightforward. With the chi-square test of independence, the null hypothesis, H0, is always that the two categorical variables are independent. In this case, it's that survival status and employment group are independent of each other. And the alternative hypothesis, H1, is always that the two categorical variables are not independent. In other words, survival status was not independent of one's employment group. All right? Finally, we had a sample of 918 Titanic crew and staff. Okay? What did we find? Well, with 2 degrees of freedom and an N of 918, we obtained a chi-square of 89.358 with a p less than 0.001. As a result, our statistical conclusions, therefore, that we will reject the null hypothesis. Survival status is not independent of one's employment group. Our substantive conclusion could be phrased a variety of ways. For example, that a crew member's chance of survival depended on their type of employment on the ship. All right? Now, a little off topic, but an interesting point. Remember that substantive conclusions can also go deeper and discuss or consider additional information that may help one to understand the statistical conclusion. In this case, why might we have seen so many of the sailing crews survive? I mean, sure, some of them may have taken advantage of their position and saved their own neck. But also, someone had to pilot the lifeboats, right? It wouldn't surprise me that this would be members of the sailing crew. So maybe some of that lack of independence reflected that there was a subset of the sailing crew that were doing their jobs. Interesting, isn't it? That's the sort of point one may include as part of their broader substantive conclusions. Okay? Now with that, let's wrap up this example of the chi-square test of independence. Hope you found it useful, and I look forward to seeing you in the next video. Take care.